Hello again. This is Math 1220 coming to you from the College U page, and the title of this lecture is Confidence Intervals for Proportions. As always, please be an active learner as you watch this video. Early in the course, we talked about descriptive statistics that described data. So we talked about things such as measures of center, means, medians, and modes, and measures of variation, like standard deviations. We also talked about measures of spread as well, using box plots and so on and so forth. Now we're going to turn our attention to a topic called inferential statistics, where we study a sample of data drawn from some population. And the definition of inferential statistics is as follows. Inferential statistics is a statistical method that deduces from a small but representative sample the characteristics of a bigger population. In other words, it allows the researcher to make assumptions about a wider group using a smaller portion of that group as a guideline. And a good example of such things are surveys. Now notice when you do surveys, there are two outcomes. You can either be for something or against it, but only two outcomes. So for example, in a survey on biometric security, 53% said that we should replace passwords with biometric security such as fingerprints. So either you were for this or you were against it. Self-driving vehicles. In a TE connectivity survey of 1,000 adults, 29% said they would be comfortable in a self-driving vehicle. The remainder said they would not be comfortable. In a Pew Research poll of 2,076 adults, 91% said they own a cell phone. 9% said they did not own a cell phone. In a Gallup poll of 1,487 adults, 43% said they had a 43% said they had a Facebook page. The rest of them, 57%, said they did not. Now, because surveys are now so prevalent and extensive, and they are widely accepted without question, we should analyze them by considering what methods were used to select the survey subjects. We saw some videos about sampling techniques, and that's an important thing. How do we use the sample results to estimate the value of the population parameters? That's what we're going to be talking about a lot in this video. And how accurate are the results likely to be? You can't be 100% sure. And typical media reports about surveys are missing an extremely important element that's usually missing. And so what is usually missing, and how do we correctly interpret such results? So we're going to be talking about these issues in this video and in the following videos. Now, if you did 50,000 sample proportions of people that were favorable or unfavorable about a topic where the mean really was 70% were in favor, this is the distribution you would get. 50,000 is a huge number, but it shouldn't surprise you. This forms a bell-shaped curve. You get a lot of different results, but they do form a bell-shaped curve. Said another way, what happens is you take sample after sample after sample. So you randomly select a value, select n values. That means you talk to n people, and you find the proportion p hat who are in favor for each sample. So we get sample 1, sample 2, all the rest of them. And the sample proportion that we want to estimate is called p, but we call each of these from the sample, we call it p hat. So you have a distribution of the p hats, and you can see here it forms a bell-shaped curve. Now what we've learned is that this sample proportions are in fact tend to have a normal distribution. They will be bell-shaped. And using the central limit theorem, we know what this normal distribution looks like relative to the original population distribution. And in fact, you can determine a number e that will be called the margin of error, such the probability that p, the population proportion, is between p hat minus e and p hat plus e, is a given number between 0 and 1, which is called the confidence level. And this is called a confidence interval. It sounds kind of mysterious, but we'll make all of this clear. So we define the point estimate is you take a good sample and figure out how many people were in favor of something, and that is called the sample proportion. That is called a confidence interval. We use that sample proportion to construct a confidence interval on the real line of the true value of the population proportion, and we know how to construct and interpret such a confidence interval. And we'll also talk about in this video how we should know how to find how big of a sample do we need to sample to estimate a population proportion with a given level of accuracy. And so here's the definition of a point estimate. And a point estimate is a single value used to estimate a population parameter. And in fact, if it's a good sample, the proportion p hat is the best point estimate of the population proportion. So for example, here's a problem. So we got a sample and we talked to 1,471 adults were surveyed, and 43% of them said they have a Facebook page. Based on that result, find the best point estimate of the proportion of all adults who have a Facebook page. You know what to do. Let's see how you did. And the answer is p hat is exactly what we got from the sample. So the best point estimate is 43%. Now, it's important to realize there can be bad samples. The math usually requires the sample to be simple random samples, and that drives the math. But often people do different kinds of samples. Also, not only must the sample chosen be appropriate, but the polling technique must happen. You can't do push polling, where you're really trying to ask loaded questions, or you can't have biases, either implicit or explicit, in your surveys. Very important topics. And the video also talked about more sample integrity matters, about how you got the sample. One of the lads who went to grade school with my children, in fact, was supposed to do a poll and just talk to people who were at their bus stop. That was a convenience sample. That doesn't give you really good results that can be generalized. Another type of sample that is bad is in a Cosmopolitan magazine, there was a survey about sexual practices among women. This formed the basis of the Height Institute, which is a very profitable thing, but this was a voluntary poll. Not everybody reads Cosmo, and you decided whether you wanted to fill this out or not. That doesn't lead to valid, very generalizable results. Okay, so why do we need confidence intervals? Well, we can end up with an estimate just from the sample, but we have no indication of how good that estimate is. A confidence interval gives us a much better sense of how good the estimate is. So a confidence interval is an interval on the real line where you go from a left-hand endpoint to a right-hand endpoint, and you make a statement like this. We are 95% confident, or the 95% confidence interval estimate of the population proportion is between. The left endpoint here would be 0.405, and the right endpoint would be 0.55. So that's an example of a confidence interval. And the confidence interval will come with a confidence level, and what we will have is 90%, 95%, 99%, or other things, and you get these from your normal tables. And as we saw in the video, this process is a very solid process, but it doesn't always work. So here is an example where the true value of P is 50%. And you notice of this, what happens is, of the 20 tries, one of them totally misses. So that is a confidence interval, the green one, that did not contain the 50. Now, so you are not certain, but you are within a statistical bound. And 1 out of 20 would be 95%. You would be correct. And what we will find is that these left endpoint is going to be p hat minus a number called e, and the other endpoint is going to be p hat plus e. Well, this e number is called the margin of error for proportions, and it's going to be a critical value that you find from your z table. And if you're going to be 90% is 1.645, 95% is going to be 1.96, and 99% is going to be 2.575. So that's the number, and this is how you know which one to use. And then this is going to be times the square root of p hat times q hat. Q hat is the same thing as 1 minus p, all divided by n. So again, this tells you a lot on this chart of how to proceed. And we're going to do more of these calculations when we pick up again. But now, more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now, more than ever, take care of yourself and of each other. Until we pick this up on the next video, may God bless you all.